this one. Okay.
Oh ya.
Tell a screen record.
Janganlah, jangan screen
Record je
record
mati
tu.
terus.
Rekod yang Teams ni lah.
Refresh.
Oh. Ni dengar suara aku lah ni. Kita orang kan? Janganlah, dah ramai dengar tu. Kau tengok, ni dah keluar.
Okay.
Ni sampai lari lah suara ni.
Filter.
Aku tutup mic lah.
Here is my link. Okay. Sudah. Okay, desktop. Okay. Should we see my desktop? Okay. Record.
Aku tengah rekod di atas orang kan? Kau still rekod juga lah kau punya?
Okay. So this is the first data, which is the full data set. Yeah. Okay. And then what we have done
Aku
is
mute
that. Okay. I ask you to do this cleaning, so I will go to the clean data. Alamak, saya tak ada ke data ni? Okay, saya tak ada lagi data tu. Okay, let me do something first. Yeah, so duration I have to do pinning, discretization. Saya tak save file saya tadi. Alright, saya dah refresh and then I did not save it. Okay, so I have to do that again. Okay, this one is 5. Okay, apply and then age. I have to change to number 13. This one is 3. Okay, and then apply. Okay, and then I have to go for rename. Okay, so selected attribute is number 2. Okay, and then apply. So I have a new name for duration. Okay, next is for age. Okay, and click apply. Okay, so this is the new data set that we have processed. Actually, we have done duration to 5 bins and then age changed to 3 bins. Okay, this data do not have any missing value and we do not do other than this lah. Let me save this. Process. Okay, this part okay. Okay, now after we have done this part, okay, we are going to do the classifications. So you can see the tab classify here. Okay. Okay, and if you go to choose here, okay, and then under 3, okay, go to the 3, okay, and then click G48, boleh? Okay, and let these parameters as default, because we are going to discuss this one later on under evaluation. And make sure this is the target that we are going to predict. Okay, and then if you look at this parameter under 3, yeah, what does it show here? This actually a parameter for us to set the tree itself. Okay, it can be binary split or it cannot. It can be not a binary split. So we choose as false, means that if it can have multi-way split, yeah. And then confidence factors, this is actually related to the impurity factor, yeah. So purity factor at the minimum 0.25, at least. This one will be discussed tomorrow actually about using the information gain to determine whether the branch is pure or not. Yeah. So we use 0.25 as the threshold for the purity measures. And then the minimum number of objects will be 2 for each branch, and decimal numbers, the number decimal places is 2. Okay. Okay, then yeah, okay, just click OK. Right, okay, and then now you can click start. Right, so what you have done is that you are applying what we call Weka classifier J48. Is actually an information gain, adapting the information gain as the measures in determining the root, the root or the importance factor in the tree. Okay, so if you look at this attributes, we have 21, yeah, 21 attributes, yeah, and then the test mode is 10-fold cross validation, yeah. The other way around, the other way that we can perform is percentage split. It would be discussed later on. Okay, and this is the model. Okay, if you look at this model, would you understand any piece of information here? Ada apa-apa yang you faham di sini? In the J48 prune tree. Anything?
It splits into a tree based on the conditions.
Okay, it's split into the tree. Okay, if you look at this, this is what is checking status? If you look at checking status, can you find any checking status? Any checking status?
Yes.
Di mana? Okay, so this is di mana? Bawah lagi kah? So this is the first checking status, isn't it? And then?
Yeah, residence.
This one is another checking status, okay? And then bawah lagi?
Bawah lagi.
There. This is another checking status. If you look at original data set, if you look at checking status, it has 4. Okay. So the tree that you develop also have 4. Apa dia? Ada 4 apa?
Attribute.
There are the 4 value, 4 checking status value. If you look at the below one here, yeah, when the checking status is more than 200, yeah, checking status is more than 200, and there is a label here, or the target. What is the target? It is good, yeah. The target is good, means that the tree has make finding patterns of if the person who have checking status more than 200, yeah. So the status of the creditor is a good creditor. Okay, ataupun a classification for the creditor adalah good, yeah. Meanwhile, if checking status no checking, Yeah, tak ada check. Yeah, checking. Right. So what is the status of that? What is the creditor? What is the category of the creditor? Is a good.
Good.
A good. Yeah. Right. So if this is the two so-called if you look at what we call apa nama samples, the number of samples. This is the number of samples, which is 63. 63. Let me count a little bit here. Let me count kejap. Saya kira sekejap. Where is my calculator? Here. Okay. 14 divided by 63. Yeah. Okay. So 14 divided by 14. This is 14. So this is 60. So not all. Yeah. I mean, the purity. The purity. I mean, the split of the branch will not gain 100% belong to good. Yeah. Okay. So not all labels will be equal to good, yeah, but there are 14%, not 40%, 40 samples, yeah, actually belongs to the other way, which is bad lah. Okay, but it is still considered because it is confidence factor is more, 63 ni more than the total of what we call 63 divided by total of 63 plus 14. Yeah, so you will get 0.81. 0.81. So 0.81 for 63 ni, yeah, it's been labeled as good because of the threshold of this or the percent of, not the percent, the percent of 63 levels belongs to good is more than 0.25. Yeah, 0.25. Yeah, just now that we look at the confidence factor. Okay, here also if you look at this one, yeah, it is more than 0.25. So we label it as good. Even though walaupun kat sini, walaupun di sini ada label yang menunjukkan apa dia? Bad. Sample are bad. Some samples are bad. Okay. Right. So that would be the apa nama the three. The three. When we have the three, we will look at the number of samples that will be belongs to the decision tree algorithms will look at the majority of samples that belongs to the labels, but not necessarily 100%. Yeah, we could have certain numbers that would not reach up to 100%. If you look at this one, this is belong 100%. Means that for this route, from this route, starting from credit status less than 0, foreign equal to until duration short, and the label is bad, and all samples, 3 samples, but it's very, very small. If you look at this, it's very small for this label. Okay. Later on I will go detail on that. And then if you go further in this results, the number of leaves is 108. So how do you know this is a 3? Yeah. So you have to look at this one. You have to look at your results. Okay. 3 will be reflect to the target itself. Yeah. So target this one. Yeah. Like this, yeah, good, bad, and so forth, yeah. This one, yeah. So this is the leaf, okay. Meanwhile, the size of tree including the intermediate nodes, okay. And this part also important because it's determine the accuracy, yeah. In classification or in the so-called training and testing concept, we will look at the performance of the tree based on the testing, okay. Let's have a look at another view context. Okay, you can go to the results here. Okay, click 3. Right, so you can see this is another perspective lah. Yeah. fit to screen. Okay. So again, I repeat, as we see in the results here, okay, you have been given, yeah, this is the this is will be the textual, the textual of the tree, yeah, giving you the antecedents and also giving you the consequence, and the consequence that been labeled as good or bad. Okay, and then if you look at the image or the tree, yeah, check-in status, and then you have foreign worker, okay, and then you would see the label, yeah. What's the difference? What's the difference between label and the notes? Apa beza dia in this figure ataupun in this image?
The notes are to test the condition.
Okay, so actually the notes is in the sphere.
Oval.
Oh, oval, ya, oval. Saya duk mencari lagi tadi. Apa benda saya cakap gelas tadi? Circle. So this is in oval, ya. Ya, betul. So the image or the attribute, the root, this is the root, and this is the intermediate nodes. So it's in the oval, yes, oval shape. If you look at the leaf, leaf tu dalam bentuk apa? This is leaf.
Rectangle.
This is, yes, rectangle. So leaf is actually the decision or the outcome or the target. So this is the target, right? Class. Betul tak? If you look at class just now. Okay, class. If you look at the class, we have good and bad. Okay, so this is the target. So means that the algorithm have construct a tree based on the list of attributes there, yeah, and then the algorithm identify which of these attribute becoming the root and becoming the what we call intermediate, okay, and then how to determine, okay, how to put it as a bad label or as a good label. Okay, so algorithms will learn it from the data set. So the algorithm use information gain, and the information gain will determine the purity of the data. As I said just now, okay, we can see it from here. Actually, the samples of how many samples, yeah, how many samples belongs to bad equal to 21 samples. Okay, and then how many belongs to good, yeah, would be 5. Okay, so most of the time we label it when majority belong to that particular value of the label, yeah. Majority must be belongs to the bad, ataupun for example if you look at here, majority is belong to mana tadi, yang ni, yang bawah tadi, majority is belongs to good here, right? Based on correct checking status equal to no checking status, majority the samples belong to the good label. Okay, and there is some of the data or the records belong to bad, yeah, but it has a, we call it here, certainty factor, confidence factor, yeah, which how many, what is the threshold, yeah, that we have to use, yeah, so that we can determine, yeah, what would be what would be how we determine if it is not majority, if it is not the all label belong to the label, belong to that value, okay, must be more than 25, 0.25, yeah. Okay, let's have a look at here back. Okay, so again, this part is the intermediate, what we call root. Okay, this one is the intermediate nodes. Okay, don't worry, I will explain what is the procedure code under the decision tree tomorrow, but today we see the outcome first. Okay, how the tree is generated from the Weka. As you see, each of the attributes will have the value, so that here if you look at check-in status, okay, if you look at check-in status, actually you have one, okay, you have 1, 2, 3, 4. Yeah, 4 apa? 4 values.
Branches or values,
Now,
yeah.
branches or the values. Okay, and if the value is more than just now, we can come up with the label or the decision whether it's good, and this one is good. But when credit status equal to more than 0 but less than 200, yeah, it will depends to the credit amount. Yeah, it will be depending on the credit amount to determine whether the samples belongs to good or bad. But for level bad, majority when the credit amount is more than 9857, okay, equal to bad. Okay, but for the lesser value, yeah, we have to look at the saving status pula. Okay, we have to look at the saving status. And then kalau saving status less than 100, kena tengok pula other parties. Okay, and if other parties equal to none, we have to look at the duration. Okay, so that will be a lot of independence variables for determining the outcome. Okay, but there are certain value, yeah, certain value of the variables, yeah, will belongs to a majority to the label of one of the label. Okay, so this will be one of the three that you have here, yeah, from J48. And if you look at further here, this will be determining, this actually representing the accuracy, yeah, the accuracy of the testing, yeah, test data. Okay, so the test data here, since we are using cross validation, is actually we are using all data set, yeah, all records in the data set. So it's produced, if you look at here, yeah, correctly classified is 718, means that 71.8% yeah, has been correctly classified. Okay, the rest is incorrectly classified. Further here, you can see the detail of TP, TL, FP. Yeah, this is actually presenting true positive, false positive, precision recall, and so forth. And how to get the true positive by looking at the confusion matrix. If you want to know what is confusion matrix, this confusion matrix A and B is actually the label, and for yeah, this one is based on the data itself. The count of A in the data and the count of what we call the count of A, the count of A in the data set, which is 599 and plus 101. Okay, but I don't want to discuss this one later on, because this is under chapters. What I just want to show the three. Okay, and what you need to know is this is actually the actual or the records of good, and this one is the actual records for bad. And what is column? Column is the predicted, yeah, the predicted of A, and this one is the predicted. The second column is the predicted of B. Okay, we'll discuss that one. No worries about that. Yeah. Okay, so what we have done just now is doing creating a model based on information gain J48 in Weka. Okay, if we have to look at the second task, then the next task is that okay, we want to do from the process credit, we want to perform this attribute select. Okay, so let's go to the select attributes here. Okay, and then let's do these two tasks. Okay, apply information gain. Okay, so click apply information gain. right? And then you prompt this info, this message, which is you have, should I select ranker methods? Yes, click yes. Okay, boleh? Boleh sampai sini? Okay, and then boleh ya? Alright, so now go to the ranker. Okay, click to the text box in the ranker. Okay, we want to choose only 5, right? So where should we change here? Where you should change here?
Num to select, maybe.
So number select, specify the number of attributes to retain. By default, -1 means that all attributes are to be retained. Otherwise, you can use other numbers, like you want to choose only 5, so change it to 5. Boleh? Click, change it to 5, and then click OK, and then click start. Okay, so you should have this apa nama, given to this information, which is attribute select on all input data. You're applying a ranker with information gain, and the rank attributes are check-in status, credit history, duration, service status, and purpose. All right, so we have here. Okay, we have here in total 5 attributes. Okay, next one, we have to apply what we call CFS, select subset evaluation. Okay, so you are being prompted with this alert, which is, should I select? Yes, click yes. So greedy stepwise. So this is another method. Yeah, just now we are using the ranker method. This one is using the greedy stepwise. Okay, same goes to this. Yeah, we want to choose only 5. So now to select, yeah, put 5. Okay, put 5. So by default, it will choose apa nama? Yeah, by default, it will go for greedy approach, maksudnya dia akan perform a greedy forward or backwards, yeah. But here we set it into, tadi apa? By default apa? False, right?
Yes.
False kan? Oh, apa yang saya buat? Okay. Okay, let me change it back. So, this one. So click OK and click start. Okay, so oops, alamak, apa yang saya buat ni? Okay, you should get another. You should get 5 lah ya. Do you get 5? Saya dah buat something tadi tu. Use the ones. Okay, not this one. Okay, you should get this one lah. Okay, do you get this one? Do this stepwise. Okay, what's the difference between greedy stepwise and ranker? Any difference? Ada beza tak?
Ada.
Apa dia? What do you see the difference between greedy stepwise and also ranker?
The number of attributes chosen.
So stepwise, as what I have here under stepwise. Do you have 5 or do you have 4 only?
I got less than 5.
Huh?
I got 4.
You got 4. So macam tadi lah ya. So my when I do stepwise here, okay, right. Let me rerun. Okay. You got 4, right? Betul tak? Ada yang dapat lain?
Saya dapat 4.
You dapat 4, eh? Okay, now let's go to the ranker. Ranker, we have 5 here, and then stepwise we have 4. Eh? Okay, right. Now let's go to ranker. Yeah. This is actually one of way to do the pre-process. Yeah. If you remember what we have done last week, what I have briefed last week. Yeah. Firstly, it's about data cleaning, and then I have data integration. Okay, and then I have what we call data apa nama?
Transformation.
Yes, transformation, and lastly will be apa dia? Lastly will be the data
Evaluation. Normalization.
Lastly would be transformation is normalization. One of way of normalization. So lastly would be data reduction.
Oh yeah,
Okay.
data reduction.
So yeah, data reduction, and one of the data reduction is through feature selection. Okay, and so this is one of functions that you can see that you can use in Weka for feature selection. Means that from original we have 21 attributes, and then we have reduced the data into only 5 attributes because we want to choose the best attributes. Okay. Right, so what we are going to do next is that right hand click to the ranker, and then can you go to you can visualize. Yeah, you can have a visualization of the data. Means that how what are the attribute involved, and then you click to the save reduce data. Okay, save reduce data, put it into your directory. Same goes to your what we call stepwise. Yeah, same goes to the stepwise. So save reduce data. Okay, done. Have you done? Dah? Okay. Dah. Kalau sudah, now you can go to the Explorer. I mean, go to your GUI. Go to GUI and then open another Explorer. Okay. Buka Explorer lain. Boleh? So let's do the classification based on these 2 new data set. Okay, give you 2 minutes to do that. Okay, boleh? So any difference that you see from these 3 model?
the greedy stat-wise gives us a better accuracy compared to the ranker and the original model.
Okay, good. Right. So you can conclude that like that. Okay. Very good. Other than that,
The size of the tree is reduced significantly for the greedy stat-wise.
yes. Okay. So if you look at the tree, you can see that the tree will be more meaningful for you, isn't it? Okay. So it's more compact, and then you could see that the what we call it, right? So you could see that the branch will be lesser, and then yeah, you only have 4 attributes here. So check his status, credit, 5 attributes here. Check his status, credit history, and then you could see that, yeah, credit amount here and also duration. Okay, let's have a view. Okay, for credit status less than 0, yeah, there is no credit status, and the credit history is equal to no credit at all. Okay, and the apa nama, the person will be considered as bad. Is it right? Okay, and then how about the existing paid and then the saving status? The person who have a saving less than 100, and then the duration is reflect to shorter, so it's considered as good. Yeah, and if we look at the duration becomes longer, the creditor becomes bad creditor. Yeah, the person becomes is categorized as a bad creditor. Okay. If it has any existing existing saving, but there is credit amount, still we could say that if the amount of the credit is more than 960, okay, it will be labeled as good. So of course here, as you see, there is numbers, yeah, numbers. So this is reflect to the numbers of sample. If you see that, but if this is not a good example, but if you see this leaf, yeah, this leaf is pure. Why pure? Because all records with these conditions, yeah, with the root, the root, this root, goes to the root, with the condition of this root, 100% or 3 samples belongs to good. So there are no other samples, no other samples like this one. If you look at this tree or this leaf, yeah, for this root, yeah, or for this branch up to the root, actually 5 samples is belongs to good, but there are 2 samples belong to bad. Okay, so this number is presenting the samples, number of samples with that target or with that label. Okay, right. Okay, if you look at the second reduction just now, which we are using this one, I guess. Okay, this one using the four attributes only. Okay, and if you see that this result shows 71, so it's much more better compared to the ranker approach just now, and also better from the original data set. Okay, so what would you see from here? Yeah, so this will be related to the one that we have done, we have seen in the Panama lecture. Actually, if you look at, maybe this data is not that big, yeah. So you cannot see so much difference in terms of timing, yeah. But you can see in terms of the complexity, yeah, the complexity of the 3 produced here. Okay, so number of leaves is lesser. Okay, and number of tree is also more compact. Okay, if you look at the previous one, which is this one, yeah, this one, I guess. Okay, if you look at this one, we are using all data. Sorry, I mean all attributes. So number of leaves become complex. 103, 108, and 143 nodes. Okay. And if you look at the 71% accuracy, yeah, so we can see that this lesser number of attributes, the model can perform much more better, yeah. And this would be good, means that somehow when we are collecting data, when we are collecting the new records to determine whether the person will be a good creditor or bad creditor, we would not to have collecting all other information like this. Okay? Means that we can ignore the employment, we can ignore personal status, we can ignore residency. We just collect data for check-in status, duration and credit, history, and also saving status. Okay, but it's always depending on the training process, yeah. How do you think? 70%, yeah, 70%. Whether it's a good accuracy or not?
I would not accept it.
So you want to have a 90%? What would be your threshold?
Above 90, close to 95 is my threshold, I think.
Okay, good. Right. So again, yeah, it depends. Depending on the situation, it's depending on the subject matter. Sometimes we say that yeah, we can accept it. Well, but probably in this situation, I guess, or I think this will be not appropriate for the current scenario, because this data could be back 10 years, 20 years. Okay, when we're looking to the current scenario, the data will be changed, the behavior of the patterns or the values, the each of the values related to the data set or related to the customer or the creditor will be changed. Yeah, so it has to be considered also. Okay, my point is that you have to look at the scenario, whether you have trained well your model based on the recent data or not. Okay. Alright, so this will be the important part that I want you to do. Okay, and then later on in this part, I will let you to do by your own. Yeah, but I want to recap, because this is just number 6, how to save the model and use the model. Please refer to the book. Okay, but I want to recap with what we have done last week. Okay, if you look at this data set, yeah. Remember that one of the tasks is that to find the outliers. Betul tak? Okay, let's recap to do the outliers and also extreme value remove what we call detection. Okay, so how you do that to find the outliers?
Interquartile range.
Okay, right, so look at the filter. Okay, and then we look at the interquartile range. Okay, so interquartile range a filter detecting outliers and extreme value. Okay, and this filter, okay, this filter can be used for nominal and numeric, or nominal only or numeric only.
Both, I think.
Both. Okay, let's go. Let's have a look at here. So it's a interquartile range, and then it's using range. Kalau gunakan range tu, what do you think?
Numeric.
Yeah, it can be used for numeric only. Yeah. Okay. So your data, because this data set has the combination, so the interquartile range is been able, but it's been able for numeric data only. If you have nominal, actually this filter will be disabled. Okay, right, let's have a look at this. Okay, click apply. Okay, and what happened after you click apply? What happened?
We get 2 more attributes.
Okay, we got 2 more attributes here. Here there are outlier and extreme value. Okay, so if you look at your data here, right, so you could see another column for outlier and extreme value, and see there, we could see extreme value in the 3rd record, 4th record, 5th record, and so forth. Yeah, let me sort it. Alright, okay, and sort this one. Okay, so when I sort it, so I can see a group of yes, yes, yes for outliers, and also yes, 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 yes for extreme values. Right, so after you have this, apa yang nak buat pula?
We need to remove the outliers and the extreme values.
Are you thinking of removing the column or what? What do you mean?
Removing the rows.
Rows. Okay, so how you remove the rows?
Instance.
Easy peasy lah, kan? So senang sangat lah kan? Maksudnya begini, right? So you can do this, and then you can do this, and then you can right hand click, and then you can delete the all selected instances, isn't it? Betul tak? Right, so says that you have lots of instances. Katakan beribu-ribu, takkan you nak buat begitu? What do you think?
We can use the filter option to remove the outliers by row.
How do you do that? Any idea?
Choose in the filter.
Cari, tolong bagi jawab apa dia.
And below unsupervised, and then instance, and then remove with values, if I'm not mistaken.
Okay, Hairul dah tahu. Yang lain tahu ke?
I'm just guessing.
How about the rest? The rest? Kamarul, Hairul pula. Kamarul tahu. The rest? Kamarul Adaha tahu. Yang lain-lain? Do you know how to do it? Tak dapat?
Sorry, I got excited again. Sorry.
Untuk apa ni?
Macam mana nak buat tu kan? So takkan kita nak remove one by one, ya? Katakan there is a lots of thousands of row. So the point is that when you have done this, you already identify, okay, these are data, this record has extreme value, this record has outlier. What is the implication if you do or use this model use this data set, use this record for the modeling? What is the implication? Do you think there is any implication?
The model won't be accurate since we are training it with the outliers.
Yeah, it will be implicates to the model, and the model will be affected or biased, something like that. So we need to remove these instances. Okay, so how to do that? Yes, tadi kayak Kamarul, kat mana Kamarul?
Instances, I think.
Kat mana? So
Kamarul.
So we need to remove instances. Yeah, remember we need to remove instances. Di mana? Okay, as you see this, yeah, we have instances remove with value. Okay, right, and then what would be our reference point? Okay, let's put it. Okay. So the command or the instruction that we are given to the Weka is that, okay, I want you to remove records by referring to the attributes, outliers, and also extreme value. But we have to do it one by one lah. Okay. So first, probably you refer to outlier. So what is the index for the outlier?
22.
Okay, and if you look at, let me bring this one. Okay, if you look at outliers here, there is yes and no. Okay, number 2. Okay, so the nominal indexes. How about the nominal indexes? Which one?
Last.
Okay, last. Boleh buat, jangan takut. Okay.
Does last mean yes in this case?
Yes, the
Oh,
second,
okay.
second one lah. Yeah, the
Alright.
second value. Okay, so tadi kita buat yang mana? Outliers kan? So now, what you got? Apa yang you dapat? There is no yes, kan? If you see here, originally the count originally the count is equal to 24. So when we apply, so there are no more records with outliers equal to yes. Okay. If you look at the data set here, right, there is all no. Yeah. Semua adalah no, ataupun you boleh tengok di sini lah, definitely you boleh tengok di sini. Clear? Okay, how to do the second one, extreme value? Extreme value
Repeat the same process.
Same process. Okay, so just change to the 23. Yeah. 23 and then click OK and then click apply. Okay, and then you will see there is no more extreme value with yes. Okay, right? So your data already clean. Okay, when you want to do modeling, with this new data set, remember ini pun kena buang jugalah sebelum you buat, because this is not significant to your model. So you remove it. Okay, try to do again. Start. Okay, what's the difference?
The accuracy increased by 1%, around 1%.
Yes, at least lah kan, at least, even though it's not much, but it increased. Yeah, it increased. Okay. So, can see the implication of having outliers in your data?
Yeah.
All right. Okay, so this will be the important parts of the pre-process. Yeah. How we did the data, how to understand the data, what are the important, because it will implicates this part. Actually, there will be lots of other algorithm that you can try here. You can try it also. Okay, but we later on will be discussing on the different algorithms, the implication of algorithms for the bahagian of evaluation later on. Yeah. Okay, so I leave you with the last task here. Yeah, save the model and use the model for new data set. New data set ni kat mana? Saya pun lupa nak tulis kat sini. Find it in team. Team. Check the data in MS Team under what we call general. New data set. Tapi tak boleh nak refresh lah kan. Okay. My new data set is in MS Team under general files, and then we call it. So it should be.
Oh, guys.
Nampak Okay.
Nampak. Cari tadi tak nampak. Tak jumpa.
So nama dia apa tadi? Which is
credit new data.
Credit new Credit new kan?
Credit underscore data.
Mana tadi? Tak boleh nak ingat. Edit new data. Right, so to leave this one, very simple, very easy. Ya, boleh buat dalam masa 5 minit saja. Okay,
Ni dia typo sikit.
macam mana?
Typo sikit.
Kat mana? Oh, kredit.
Madam, untuk Weka
Ya.
tu kan, yang minggu lepas punya lah, saya ada buat yang masa nak ubah data mana dah saya tak ingat. Ada bila saya apply tu dia macam tak berubah. Ada satu step saya tak ingat. Dan
Ya.
bila saya apply, saya pilih yang apa tu, yang attribute dia sekian dan bila saya apply tu kadang-kadang dia jadi, kadang-kadang dia tak jadi. Saya tak tahu, saya tak select dekat tu ke. Dia memang kalau kita nak apply kita memang kena select specified punya tu attribute.
Tu kalau lebih lebih tepat kena specify lah the numbers tu, the number of indexes tu.
Oh.
Doctor, the new dataset uses the ranker, is it? Because it has 5 attributes instead of 4?
Yes, betul. Model
Ranker.
yang khusus adalah ada 5. Ya.
Alright, no problem.
Okay, don't forget to record your attendance. Anything else, I still stay, for within 10 minutes. Okay, siapa-siapa yang nak leave dulu pun boleh, tak ada masalah.
Okay, thank you. Selamat
Okay.
Selamat berbuka.
Selamat buka.
Thank you, madam.
Madam.
Thank you, madam.
Welcome.
Bye, madam.
Alright.
Thank you, madam.